Hello everyone, I hope all of you are doing well and staying safe. Welcome to the new concepts lecture. Now you're done with the logic paradigm and with the also functional paradigm, and it's time to move on to a new paradigm. The paradigms we've studied could be classified under the declarative paradigms, where the focus, as we said, was on the what and not on the how. So in order to solve the problem, you had to describe it somehow. You had to think of what you want to have, what is it that you're interested in, okay? However, with this new paradigm that we're studying, with the imperative programming paradigm, the focus is actually on the how, okay? As from the name, imperative, they are orders. So what you do is you give the program exactly the orders or the instructions or the commands that you wanted to execute. And this is why you actually need to think of what you want to have and how you will be able to execute it, or how you will be able to compute it, or how you will be able to solve such a problem. Now, the idea is that, for example, with Java, you've been doing things that look like that as well. You've been thinking of the how a lot. However, Java, as we said before, is an intersection between multiple paradigms. So Java is considered to be imperative, however, it's also object-oriented, and you are actually studying Java as an example of an object-oriented language in your 401 course. Okay, so today or throughout the coming lectures, we will focus on C as an example of an imperative programming language. Okay, now if you think of C in this case, and as an imperative programming language, it has the notion of a state. Okay, so what is a state? A state is basically, it is called the state of the execution. So it's basically sort of what do we currently have. So you can think of it as, for example, a list of the variables and their values, or a list that maps between memory locations and values. Okay. And what happens is, as you execute the program, as you execute the instructions of the program, this state will change. So it could change by adding new things to it. It could change by changing one of the variables in the state. And this is why we say that in these languages, we have what we call the side effects. So basically, with the side effects, what you can have is you can reassign a value to a variable, and this is something you would have never been able to do with a language like Prolog, for example. Okay, so with imperative programming and with the existence of the notion of state, we have different features that we can use, like the side effects and the reassignment of variables. So this is, for example, something that you have been doing in Java. So in Java, you've been assigning and reassigning variables and values a lot. However, you did not know why you were able to do it. And now you know that this is a feature that actually does not exist in any language, and it depends on the paradigm of the language and on the existence of these states. Okay. Now, how does a program that you write get executed? So before we go and we start to write our first program together, we have to know how actually the programs will be executed. Now, C is actually a language that is compiled, which means that the source code that you write at the end of the day is translated into a file that contains the machine code, the executable file, the file that you can execute on your machine right away. Now with this, you can ask a question of whether C is as portable as Java or not. Okay, now the answer is it is portable, but not as much as Java. So it could be that from one machine to another, you might need to do some changes. The changes are minimal. If you would need to do some changes, they would be minimal, okay? But it's unlike Java, where you write once and you execute everywhere. Okay. Now, what actually happens is you have your source code, and in your source code you can include a header file, and these are similar to libraries that you can import, for example, and then the compiler would take these and they would compile the files, okay, and this produces something that we call an object file. Okay, and then what actually happens is this object file, okay, because your application can contain different files or different let's say programs. Okay, so what happens is we use something that we call a linker, and this linker, from the name, it links the different files together. So these files could be the different files of your application, or it could be your object file and another library file or whatever. Okay, and using this linker, okay, after the linking process happens, the final executable file is produced. So I just wanted you to know the term linker, okay? But the main idea is, the most important thing you know is that C programs are compiled. So at the end, we or the system would produce the machine code. And of course, by now you know what machine code is, and this is the code that is understandable and executable by the machine right away. Now, let's go and let's write our first program, and of course it would be a hello world program. Okay, and to do that, let me show you the different options of writing C. Now, you can go and you can download an IDE. Okay, this is called DevShed. Okay, this is one option that you can go for, and in this case you would be writing your files locally, saving them, compiling them, and running them. Now, another option to use an online website like REPL-IDE, okay, that has this website supports different languages. It supports C, it supports Haskell, it supports different things. Okay, so you can just write your code on this website, and in this case you execute it on the website, and the output, or this is sort of the console. Okay, and this is what they call an online IDE, for example. Okay, so let's move on and let's take a look at our first example. So as you can see, this is actually the hello world that we want to go ahead and write together. Okay, so let me go to my desktop IDE, okay, in order to write everything with you from scratch. Now, the first thing I want you to know is when you save your files, okay, in this case, I will save it, I will call it hello, okay. I have to make sure that the extension is .c, okay, because by default it will make it C++ or CPP, okay. No, we want it to be .c because there are some differences between C and C++, okay. So now I have my file, it's saved, I can go ahead and start to write my code. Now, similar to Java, in C, we also execute the main function. In this case, we call them functions and not methods, okay? Now, there is a big difference here, and it is that the main is a function that returns actually an int value, okay? It's not a void function. So in this case, I will go, this is my function, and because it's an int function, it has to return something. Usually, it returns a 0, okay? And usually, a 0 in this case would mean that there is no problem. So usually what the convention is, when you have a function, an int function, and this function returns a 0, then this 0 would mean there is no error, okay? So this is why we make it return a 0. So this is basically a program. It's a program that does nothing, but it is a program. Okay, what I will do next is I have to compile first and then execute. So in this IDE, you go for execute, compile, and then run. So I will go for the shortcuts always, so you'll not see me going for this menu. I will press F9 to compile and then F10 to run. Okay, so I press F9. And in this case, as you can see, I don't have problems. So I press F10 and basically this is what I get. Okay, so there is no output really, because I did not ask it to print anything. So it just says that the process exited after this much time with a return value of 0. Now this could look different on a different IDE. So basically what usually happens, or what happens in a lot of IDEs, is if I do this kind of program, what will happen is I will get my console, but it will disappear instantly. Okay, I don't get it to sort of freeze until I press any key. Okay, and this is why in a lot of programs you will find us writing this function, and this function is get character. Okay, what does it mean? It basically means that it's waiting to get a character from the user, an input character. Okay, so it's basically as if you're scanning for an input character. Okay, so if I compile this, okay, and then I run, okay, as you can see, now it looks different. I did not get that the process exited, because now it actually is waiting for a character for this in order to be able to go to the next line and return. Why? Because this is a procedural language, and this function that you wrote is sequential. So it has to do this step, and then it goes for that step. It then goes and returns. So I will enter any character on the keyboard, okay, and once I do that, it goes to the next line, and the next line returns the 0, and once it returns the 0, it actually prints that. Okay, and as you can see here, the time became much more, because now we actually waited some time before I entered the character. Okay, so as we said, this will differ from between the compilers or the IDEs that you're using, so that's why we usually put this line at the end of our main program. So let's now go to the hello world program, and in this case we actually want to print hello world. So to print in C, the function is called printf. So I go and write printf, and then my string hello world, and then the new line escape character, which is the same like the one of Java. Now, the thing is that the printf actually, in order to be able to use it properly, it actually exists under, or it's used within an external header file, which is similar to, for example, libraries or classes or packages that you would import in Java. So in this case, I have to go and I have to include the header file stdio, okay, and this is the standard input output, okay, and we usually also include the conio, which is the console input output. So usually include these two, and they are basically used for the purposes of scanning and printing and so on. Okay, so now I will save my new file, I will recompile, and now when I run, I get hello world. And now it is still waiting. Why is it waiting? Because of the get ch. So I will click on any key, and then it just returns. Okay, so this is our first and simple hello world program. Okay, so let's move on and see what we can also do with C. Now, of course, there is a lot of resemblance with what you were doing and what you can do with Java and Python, for example, okay? So the thing is, you need to know whether there's a difference in the existing data types, in the syntax, and so on. And this is what we will learn as we move on today. So the first basic thing now is the printing is done with a function called printf, okay? Now, let's move on to data types. Okay, the basic existing data types are ints, floats, and characters. Okay, we also have doubles and we have longs. Okay, but these are the three basic ones. So I can say int x is equal to 5, and then I can reassign the x. X is equal to x plus 2, or x plus equal 2. Okay, so in this case, what's the value of the x? The value of the x is 7. Okay, I can also go and define float y equals 2.5. Okay, so As you saw, all my lines end with semicolon, just like Java. Now, what I want to do is I want to print a statement that says the value of x is equal to, and then the value, which now is 7, but I don't know this because the program will compute it for me, and I will print and the value of y is, and then I get the 2.5 print. Now, what you would do in Java is you would do something like that. The value of x is, and then plus x, okay? Now, if you go and you compile that and you run it, you actually get the value, okay, of x is, and then you get nothing printed, okay? Why? Because what you actually need to do in C is different, okay? What we do in C is when we want to print a statement, and within the statement we will print the value of a variable, we do not concatenate it with a plus. We actually use the comma. So I want to print the x, okay? Where will I print it? Here. This is what you need to tell C at this point. So by default, C will not print it at the end of this statement, okay? So I can then go and say the value of y is, and then here I want to print the value of y, so I will say comma y. So now I have a big statement. However, C does not know where exactly inside this statement do you want to print this value and that value, okay? So in this case, what I will do is I will say that here I want to print the value of x. How do I signify this? We signify it by a placeholder. So in this case, I will write %d, okay, decimal. Okay, what does this mean? This means that in this place, okay, what will actually be printed is not %d. It's the value of a decimal. What is this value? It's actually the value of x. Now, if I stop here, what do I get? Think about it. If I tell you, please trace this program, what do you get printed? What you will get printed is this. Of course, you get the hello world, and then you get the value of x is 7, the value of y is, and then you get nothing. Why didn't I get the value of y printed here? Because I did not specify that here I need to print something. I just have a space, and this is what you got printed. What if I want to print the value of y? I have to also specify it with a placeholder. Now, in this case, the placeholder will look different, will be different. Why? Because in this case, I'm not printing a decimal value, I'm not printing a whole number, I'm actually printing a floating point number. So it will be %f. So if I recompile and run, now I actually get the correct value, okay? So in this case, as you can see, the number of arguments that the printf statement will have will depend on the number of placeholders that I have. So in this case, if I only want to print the x and I will remove this, then there is no need to have the y because I will not use it, okay? So in this case, I'll only have one, in this case, variable x, which I want to print. Okay, now the order in which these values will be printed will be exactly the order of the placeholders. So this is my first variable x, so it will replace this placeholder, and this is my second variable y, so it will replace my second placeholder. Okay, now what if instead of having %f I have %d? This should be a problem because in this case, the y is actually a floating point number. So if I compile and run in this case, as you can see, I get a wrong value, okay? So it's crucial that you write the correct placeholder for the corresponding variable that you want to print, okay? So now, as we saw, we actually don't have a built-in type for booleans, okay? So in C, there is no such a boolean data type. However, if you try to evaluate a condition, you will either get a value 0 or 1. 0 would mean that the condition is false, and 1 means that the condition is true. So in this case, what I want to do is I will comment these, okay, and I want to write a program. I have 3 variables, x, y, for example, is 10, and z is 50, okay, and I want to print which variable has the most or the maximum value. Another way to declare these variables is I will declare y and z both to be integers, and then I will assign the values for them, okay, also similar to what you can do in Java. Okay, now I will go and I have at this point to start to use conditional statements. So far we've only had sequential statements. I want to go and I want to have conditional statements. So it's exactly similar to what you would write in Java. So in this case you can write if y is greater than z and, which is and y is greater than x, then in this case the maximum value is y. So printf y is the maximum, okay, and then you can have your else, okay, so else, and then you say if in this case the x, for example, is greater than y and the x is greater than the z, then in this case the x is the maximum. Else, what you can do is, without checking, you can print right away that the z is the maximum. Okay, so in this case, if I go and I compile, sorry, let me compile first, and I run, I get that z is the maximum, which is correct. Now, if I make this 100, for example, then I get that y is the maximum, which is also correct. Now, if I make this 200, then I get that x is the maximum. Okay, so in this case, you can still write the conditions. You can compare equality with equal, inequality with not equal, okay, and so on. Okay, you can have a greater than equal, less than equal. You can have the normal conditions. Now, if I want to print the value of this statement, okay, I want to know what it evaluates to, in order to see that we will not get the keyword true or false that we're used to see. Okay, so I want to print f, and in this case I will print the value of my condition is, and then it's a decimal value, and I will write this expression. So in this case, this expression is evaluated, and the value of this expression will be put here, okay, in this place. Okay, so once you print, you get that the value of my condition is 0, and 0 in this case means that it's false. Okay, why? Because x is the maximum. So if instead of printing the value of this condition, you print the value of that condition, you actually get the value of my condition is 1. Okay, so in this case the conditions evaluate to 1, which corresponds to true, okay, and 0, which corresponds to false. And one more thing regarding the prints is what you can write here could be expressions. So what you can do is you can print, for example, x plus 2. Okay, so in this case, or let's for simplicity, z plus 2. Z is equal to 50, so z plus 2 should be 52. So I can write the value of z plus 2 is, and then I compile, I run, and I get the value of z plus 2 is 52. Okay, so in this case, you should now be able to write the normal programs that you can do. Okay, you know the basic data types, you know the basic constructs, sequential and conditional, and you can also do loops. Okay, so in this case, let's try a for loop together. Okay, so if we try to do it the same way, okay, for int I equals 0, I less than 10, I++, and let's assume the aim of this program is to evaluate the value of the sum of the numbers from 0 to 9. So in this case, I have a result accumulated, or an accumulated result, to which I will add I every time, and then at the very end I will print f, the final result is, and then comma, result accumulated. Now I'm missing something here, which is the placeholder, and let me just add a new line. Okay, so here it looks okay, but if you try to compile it, you'll get an error. Why? Because in C you cannot declare this here. Okay, you have to do it outside, and then you can use it inside as a declared variable. Okay, so once you do this, this will run and you get that the final result is 45. Now, if I want, okay, to print every time what is the result so far, so what is the result after adding one number, what is the result after adding two numbers, what is the result after adding three numbers, and so on. So in this case I have to have braces, okay, similar to Java, okay, because I have more than one statement in the body of my loop, okay. And in this case what I will do is after I add, okay, I will print that the new sum after adding some numbers, okay, is, and then a value. Okay, so in this case I will be printing two things. This represents the number of steps and it's a decimal value, and this represents the new sum, which is also a decimal value. Now the new sum, which is the second number I print, okay, is the accumulated result. Okay, so here I have my accumulated result. What is the first number I print? It's actually the number of steps or the number of times I've done the addition. So the first time I entered the loop, how many numbers did I add? I added one number. Okay, if you try to print here the I, it will be a problem. Why? Because in the first time you enter the loop, the I is equal to 0. However, you performed one step. So instead of printing the I will be printing the I plus 1. So I'm not actually changing the value of I, I'm only printing the I plus 1, okay? And this is similar to what we did here, which is we print the value of the evaluation of an expression. So we get an expression, we evaluate it, and we print the output of it, okay? So if I save and I compile, now I'm missing something, which is the semicolon. Okay, now the new sum after adding one numbers is 0. The new sum after adding two numbers is 1. The new sum after adding three numbers is 3. And as you can see, the new sum after adding 10 numbers is 45, which is the same as the final result. So this is actually the correct way. Okay, so as we saw, we can actually do almost the same things that you know, but there are some slight differences in the syntax, which we've done some examples with. Okay, now let me show you some other things in the slide. So we've already done this example, and we know that getch is actually used to hold the execution, okay? And we've taken a look at the types. Now for strings, okay? Also, you might think that string is one of the types that has to be there. But as you saw in Haskell, okay, Haskell deals with strings as if they are arrays of characters, and C also has the same thing. So we do not have a predefined type string, okay, but it has a special treatment, okay. So although it's not predefined, in this case C, okay, system would know that this has a special meaning, okay, and the meaning is that it's an array, it's a list, it's a sequence of characters, and the char or the character is the built-in data type, okay. So if you want to define a string, you have to define it as an array of characters. Now, if you take this and you go to our program, and actually in this case I want to print, okay, my string, my name. So in this case the question would be, what is the placeholder that I put here? And this is why here I tell you that the string has a special treatment. Although it's built in, however, it has its own placeholder. Why? Because it's widely used. Okay, so instead of you having to loop on the array and print character by character, there is a way to do it in one tile by using the placeholder %s. So once you compile and you run, you get the string printed. Okay, so you should not confuse this with arrays in general. Okay, because with arrays in general, you might not be able to do something like that. Why am I able to do it with strings? Because although it is internally defined as an array, it still has a special treatment. Okay, now there is another way to define an array. So this is, it looks like the normal way, okay, char, which is the data type of every element of the array, the name of the array and the length of the array, and then this is the value, okay. And in this case I have the characters S, L, I, and M. Okay, now there is another way, as you saw it in the slides, which is instead of using this, okay, the squared brackets, I will use this, okay, and this looks like a char, but it's not a char. It's what we call a char pointer. So in this case, a char pointer, okay, is the place, okay, of a character. Okay, so my name in this case does not hold a character. Okay, it holds the address of a character. Okay, so for now that's enough, okay, regarding the pointers, because in a couple of slides we will go into the different types of pointers. But for now, I just want you to know that these are two different ways to do the same thing, which is to define a string which is actually an array of characters. Okay, how does pointers work, we will see in a bit. Now, before we go to that, of course, this is something we've taken a look at. If you want to print, in this case, a string, if you want to print a floating point number, if you want to print a character, and this is if you want to print an integer. Okay, in the program I've used with you the D. Okay, you can use also the I for integers. Okay, now this is if you want to print different things, you have to have the different placeholders for them. Okay, now if you want to increment values, and you have this, okay, also this is something you might already know. If you have a equals to 2 and then b is equal to a plus plus. Now, the a plus plus means that the a is incremented, definitely. Okay, so the a becomes equal to 3. However, what will the value of b be? In this case, the value of b is the old value of a, which is 2. If you do it the other way around, if you have a equals to 2 and then b is equal to plus plus a, now in this case, the value of the a is incremented first, okay? And then the new value is assigned to b, and this is why b is equal to 3. Unlike here, the b is assigned to the old value of a, and then the value of a is incremented, okay? So this is something that you might find in some tracing problems that you will see in the practice assignment, for example. Okay, now, in C, we still can define functions because we still want to have our code in a modular and a readable way. Okay, so what we can do is we can go and we can define our own functions, and there are built-in functions that we can use, like for example the printf. Okay, the functions in general would have a return type, would have an identifier and a parameter list. Okay, and the return type can be void if the function does not return anything. Okay, now let's take a look at an example. Now here I've created a function, it's called equal 0, it returns an int, and it takes two parameters which I've called a and b, and they're also integers. And what does it do? It checks if one of the inputs is equal to 0. So here you see the or, okay, which is the or. Okay, so if a is equal to 0 or the b is equal to 0, I return 1, else I return 0. And now I will, in the main function, create, for example, var1 is equal to 0, var2 is equal to 1, and then I print f, the result of calling the function, or let me call the result is, and it's a decimal or it's an integer. Okay, and in this case it's equal, I call equal 0 with var1 and var2. Okay, I will compile, I just rewrote this to the correct spelling, and I will run. And in this case I get a result is 1. Why? Because in this case, as you can see, one of my variables is actually equal to 0. Let me make this a 2 and rerun. In this case, result is 0. Why? Because none of my variables is equal to 0. So as you can see, in this case, what I did is I called a function. It could be that instead of doing this, you can just return the value of this expression. It's exactly the same. Okay, you compile, looking at this, and you run, and you get the result is 0 in this case when the two variables are 1 and 2, and if you make one of them 0, then the result becomes 1. Okay, so in general you can still create your own functions and you can call them. Now let's try to go into pointers. Okay, and to do so I want to go into the idea of how the parameters are actually passed into a function. Okay, and in this case we have two options. We can either pass them by value or by reference. Now in a lot of cases, we might ask you, for example, to trace what happens here. Okay, so let's take a look at a general scheme of tracing. Let me just remove that. Okay, and in this case, what you want to do is you want to make sure that you understand the scope of every variable. Okay, so every variable that you create is actually created in memory. Okay, and it's a matter of what can access which parts of the memory and what can see which parts of the memory. Okay, so in this case, what we will have is, usually what we do is, it's an easy way to trace. Okay, we create for every, in our case, function, okay, a box. So let me draw a box. So for the main function, I have a box, and this box is the main. So I write that this is my main. And inside my main, what do I have? I have var1, okay, which is actually equal to 2, and I have var2, which is equal to 0. Okay, so these are my two values. Now, these are the first two statements, and once you've created these two variables actually in your memory, so if you have another box that represents your memory, okay, let's do it like that. In your memory, you will have one place for var1 and another place for var2. Okay, so in this case, this is var1, for example, and this is var2. Now, what will happen? What happens is you call the function equals 0. Once you call the function equals 0, then a new box is created, and this box is for the equal 0. Okay, so in this case, I have the equal 0 box, and this is it, equal 0. Now, what will happen? Before you actually go and you start to execute what the function wants you to do, okay, you have to take a look at the parameter list of the function. Okay, so in this case, the parameter list of the function is a and b, which means that this function is expecting a value for the a and is expecting a value for the b. Okay, before you go and you try to do anything, it's expecting the values. It cannot work without you supplying the values. What value will you supply? I will supply in the first argument the value of var1. What is the value of var1? It's 2. So what I supply is the value. So I send a copy of this value here. So here what I will have is I will have the value 2 as my first parameter, and here I will send the value of var2, which is a 0. Okay, so I send a copy of var2 as my second parameter. Now the equal 0 can run. So what will I do? I will forget about my main, because now I'm executing my equal 0. What will my equal 0 do? It will return the value of this. So it will evaluate this, and in this case, what does it return? It returns a 1. So I know that this now will exit and it will return a 1. Okay, so once this exits means that this is removed. Okay, however, it's removed with a value returned back equal to, in this case, a 1. Okay, what the main will do is it will take this one and see what do I want to do with it. In this case, I want to print it, so I will print it. Okay, now let's go for another example. In this case, let's take a look at this example. In this case, my main function is, or in this case, it tries to swaps two values. Okay, so it has two integers a and b with the values 2 and 3, and then I call the function swap ab and I return. Okay, the idea is, does this swap actually happen? So if you print afterwards a and b, will you get the a value to be 3 and the b value to be 2? This is what we want to trace. Okay, take a look at the swap function. In this case, it's a void function. It has two inputs, x and y. And in this case, you create a variable temp and you assign the temp to x, and then you assign the x to y, and you assign the y to the temp, which is the old value of the x. So let's trace it. In this case, I will start with the main. In the main, I have a, which is 2, and let me write it with a comma, b equals, or let's do it on two different lines, and b is 3. okay? And then once you add these two variables, they're added in the memory. So somewhere in the memory, I will have the A whose value is 2, and I will have the B whose value is 3. They are in the memory, okay? And they are seen here, okay? So can the swap access this value? In the swap, can I use a variable called A? No, because of the scope of the variable. So the scope of the variable A is only inside the main, and this is why I personally like to use these boxes, because they let me visualize the scopes of the variables, okay? Now, if you go and you call the swap, then automatically the swap is waiting for an X and is waiting for a Y, okay? Automatically, it's waiting for these two values. So it's about what do you supply. In the value of the first parameter, in the value of the X, what do you supply? You supply the value of A. So what do I supply? I supply the 2. So the value of X is 2. Okay, and the value of the Y that I supply will be a copy of the value of B, which is the 3. So I supply here the 3. Now what do? I forget all about the main, and I start to execute my swap. What do? I create a temp, and the temp will be equal to the value of X, which is 2. And then what do I do about the value of X? I will change it. In this case, the value of the X will be the value of the Y, which is 3. And then you go to the Y and you also change the value to be the value of the temp, which is actually 2. And now you're done, okay? So now I will just exit, okay? Because it's a void function. So in this case, once you exit the function, these, let's say, variables, these things that you've created are removed. And now, let's take a look at the main. Did anything happen to the values of the A and the B inside the main? No. They're actually the same as they are. Why? Because what we did is we actually took a copy of the A and a copy of the B, and we actually swapped them. So if you take a look at these, they're swapped. But what did I swap? Did I swap the original A and B? No, I swapped a copy of the A and a copy of the B. But the original values, the original variables are as is. Okay, so this is where the pointers will come in handy. Let's take a look at what pointers are. Actually, pointers should remind you of the indirect addressing mode that we've been dealing with in CO. So if you remember, in this case, some of the cells in my memory will not contain the operand right away. The cell would contain the address of the operand. Okay, this is exactly what a pointer is. So the pointer is basically a type of data. However, the data that I can save in a pointer is only an address in the memory. Okay, so in this case, if you take a look at this example, I have int x, okay, equal 10, and then what I have is I'm printing the value, the address of, and then placeholder for a decimal is, and then a placeholder for an x. Okay, what does this mean? In this case, this actually is a hexadecimal value. And why is that? Because the first thing I will print will be the value of x as is. But take a look at the second thing I print. I print and x. What does and x mean? In C, if you precede a variable by and, then this means that this is actually the address of the x. Okay, do you know where the x is saved? No, but C would know. So once you ask C to print it, it will show it to you. And this is why C is considered as, compared to Java, for example, as a lower level language. Why? Because you get to deal with things like that. You get to deal with the memory, you get to deal with the addresses, you get to deal with the allocations and the freeing of the memory manually, as we will see next time. Okay, so let's try this together. If I compile and I run, I get the address of 10. What is this 10? It's the x, which is this decimal value, is, and then this is the value of it. And this is the value of the address in which the, in this case, variable x is saved. Okay, what if I want to save this value in a variable? Okay, so in this case, I know that the value I want to save is and x. Okay, where will I save it? Can I save it in an integer value? No, it's actually not an integer value. It's a hexadecimal value, and it's a special value because it's a value of an address. Okay, and this is why in this case I will not say it's an integer. I will say that basically I cannot call it x, okay, because x is already taken, so I will call it p. And in this case I will say that it's an integer pointer. Okay, How do you know that it is a pointer? You know that it is a pointer from this asterisk. So if you remove this asterisk, then this p becomes a normal integer, okay, just like the x. Once you add this asterisk, this p is no longer an integer. It's an integer pointer. What is an integer pointer? An integer pointer is a pointer. So it's a normal variable. However, the value inside it has to be an address, okay? Okay, so far it should be clear. However, if I do this, it might be a bit confusing. If I say char c is equal to character a, and then I have another pointer, but in this case it's char asterisk p2 is equal to and c. Now, in this case, I still have no compilation problems, but why in this case is it a char pointer instead of an integer pointer? Take a look at these two lines, line 7 and line 11. From them, there should be some kind of a pattern that you can use to know why we actually had a different declaration on the left-hand side, okay? Now, as you can see, in both cases, the P and the P2 are pointers because I have these asterisks, which means that the values saved inside P and P2 will be addresses, not normal values. However, the value saved inside P will be the address of X, and X is an integer, and this is why P is an integer pointer. It points to an integer. And the value saved inside P2 will be the address of C, and C is a char, and this is why P2 is a char pointer, okay? So, if you try to do it differently, so in this case, if I say that P, I want it to be a char pointer, I actually get a problem. Why? Because C will tell you, now you want the P to hold the address of X, and X is an integer, so P has to be an integer pointer. Although it will still hold an address, but you need to say here that it points to an integer, okay? Once you do that, the compilation is okay. Now, you can of course also do it on two steps. Declare the P first and then assign its value to be the address of X, okay? Another thing that you can do with pointers is the other way around. So, if you think about what this will look like in memory, it might actually look like this. So what do we have? We have in the memory a variable X with a value 10, and this has some address, whatever the address is. This is just an example. And then we have another variable, which is P. However, the value of P is linked to this address, okay? So the value of P is the address of X, whatever the address of X is. And this is why we usually do it with this way. We have sort of a pointer or an arrow of the P pointing towards the X, which means that the P holds the value of X, okay? What if I do not know what the value of X is, okay? So what if the value of X changed? I have some instructions that would change the value of X, and I want to get the value of X using the P, okay? So I know that the P points to the X, it holds the address of the X. Can I access the value inside this address, okay, without using the variable X, but only using the value P? Yes, I can. How do I do so? Let me go back here and write. So in this case, I want to get another decimal value, okay? So in this case, let me do it with another print statement. So I can say the value is, and then if I go and I print the P, then what will I be printing? Will I be printing the value of X? No, I will be printing the address of X. In order to get the value of X, I will apply an operation on the P, on the pointer, which we call dereferencing the pointer. How do you do it? With the asterisk. So once you say asterisk P, this means that you are not interested in the value of P. You are interested in the value inside this address. And the value inside this address is actually the value of X, which is 10. So if you print, you get the value 10. What does this mean? This means that you can actually go and do this. I can say asterisk P plus 1, okay? And in this case, I want to print this, okay? So instead of printing asterisk P, I print asterisk P plus 1, okay? So asterisk P will get you the value 10 plus 1, this will get you the value 11. However, if you go now and you print the value of X, what will the value of x be? The value of x is still the 10. Why? Because here you went and you got the value inside the cell, which is 10, and you just add 1 in the printing. But did you reassign this inside the cell? No. So the value of the x is still the 10. What if I want to change the value of the x to be this new value? Okay, so in this case, I can do this. I can say x is equal to this new value, or instead of using the x, I can do this. I can say that whatever the p is pointing to, the value inside it, I want it to be this value. This value we already know is 11. So now the value that the p is pointing to will become 11. So if you go now and you print, the new value of the x is 11. So how did this happen? This part means I will go to the p. What does it point to? It points to this place, and this place holds the value 10. So this basically is a 10. So 10 plus 1 is equal to 11. Now, this 11, okay, what do I do with it? I will go to wherever the p is pointing to, and I will change its value to become 11. Okay, now let's use the same concept and try to do the swapping. Okay, so this is the other option for the swapping. Okay, and in this case, as you can see, the swap function is actually defined a bit differently. In this case, instead of taking 2 integers, it takes 2 integer pointers. Okay, so it basically takes 2 addresses. Okay, so I've made this just to make things faster. So what we have is we still have in the main function inside this box the 2 values a and b defined, okay, which are 2 and 3, and then I will call swap. Once I call swap, I have to make these 2 parameters ready, okay, and as you can see, I have the a and the b, which are in some place in memory. I don't know the addresses, but they are definitely inside my memory. Okay, once I call swap, I have to supply a value for the first parameter and a value for the second parameter. Now, for the first parameter, what do I supply? I will supply the value of and a, which is the address of a. Okay, so this is the value that I supply as my first parameter. Okay, so let me write it. So in this case, x would be the address of a. What's the value of the second parameter? The value of the second parameter in this case will be the address of b, whatever the address is. So I know now that x is a pointer. Where does it point to? It actually points to the address of a, which means that if I do that, then this will be my x and this will be my y, okay, because they are 2 pointers. So now, did I send a copy of the a and a copy of the b? No, I sent the address of the a and the address of the b. So now let's move on. The first thing I will do is I will have an integer value, and this integer value is called temp. And in this case, the value of the temp will be will be asterisk x, okay? Which means that the value of the temp will be whatever the value inside the x, which now is 2, okay? And now, asterisk x equals asterisk y. Let's start with the right-hand side. What is asterisk y? It's the value inside the y, which is 3. So now, the right-hand side, this is actually 3. If you write this, then this will be 3. What do you do with this 3? You take it and you assign it inside this, which is inside whatever the x is pointing to. So now you go here and you change that to be a 3. Once you've done that, okay, as you can see, this is a change in the memory. This is not a change in the value of a copy. This is a change through the address, so it's reflected in the memory. Okay, now asterisk y equals temp. Temp is actually equal to 2, so asterisk y, which means this will be 2. And now you return from that. Now this is removed. Once this is done, take a look at what happened. Is the a value still a 2? No, the a is now a 3 and the b is now a 2. Why? Because now the value of the a was changed through the pointer, through the reference, through the memory to have the value 3, and the value of the y was changed to be a 2. Okay, so as you can see, you can use the addresses in order to make sure that the change is reflected everywhere. It's not a change in the copies only here, it's a change through the memory and it's reflected everywhere. Now, let's take a look at another use of pointers. Now, the next use of pointers would be with arrays. Why? Because at the end of the day, an array is a continuous block inside the memory. Okay, so we can have arrays. You can initialize them just like what you would do with Java, for example. Okay, and in this case, what I want to do is I want to print the values of my array. So this is one way to go, which is I have a loop, and every time I access the array at index I. Okay. Now, another thing or another way to look at it is that whenever you initialize this array, the variable array, the variable ARR, is actually a pointer. But what does it point to? It points to the first element of your array. So take a look at this print statement. What do I have? First value, and then I print asterisk ARR. When can I apply asterisks on something? If this thing is a pointer, which means that this is actually a pointer, because when I compile, I have no errors. Okay. Once I do asterisks of a pointer, this means I will access the value that this pointer is pointing to. Which value is the pointer pointing to? It's pointing to this value, to the address of this value. So if you do asterisk ARR, what value do you get? You actually get 4. Okay. So let me comment this and run. And you get the first value is 4, which is okay. What if I want to go to the second value? In this case, can I still have asterisk ARR? No, because asterisk ARR will still print the same value 4. What do I want to go for? I want to go to the next address, okay, to the next consecutive address. Okay, now let's think about normal values. If you have an integer value I, okay, 0, and then you say I plus 1. What will I is equal to I plus 1? In this case, what will the new value be? It will be 1. Okay, so the displacement between the two consecutive values of integers is 1. Okay, the displacement between the two consecutive values of pointers is 1, in this case, address. Okay, so if you're doing hexadecimal, for example, and every word takes one place, then in this case you start with 1, 2, 3, 4, and so on. Okay, so in this case, if you say ARR plus 1, okay, without this asterisk, then this means that you are incrementing the pointer ARR by 1, which means that instead of pointing to this, okay, ARR plus 1 will point to the next address, will have the value of the next address. Okay, whatever the displacement is, it could differ according to the data type, it could differ according to the operating system. I don't care. I just write plus 1 and it will handle it automatically. So once you say asterisk, in this case, once you print, okay, let me compile. Run, I get the second value is 6. Okay, so basically this is the value of ARR. So ARR plus 1 will be the next address. ARR plus 2 will be the next address. Okay, so one other way to print is to use ARR as a pointer. So in this case, ARR plus I, okay, which is still a pointer, and then you do the dereferencing, you do the asterisk. So in this case, in the first loop, it's ARR plus 0, which is ARR, which is the address of the first element. In the second loop, it's ARR plus 1, which is the address of the second element. In the third loop, it's ARR plus 2, which is the address of the third element. And then you do the dereferencing in order to get the value inside. Another question we usually get in this lecture is whether you can have a pointer to a pointer. So if you have int x equals 10 and then you have int p, okay, however it's an integer pointer which you can define this way, okay, equals and x, so it's the address of x. You can have it int asterisk p, okay, this way, this is okay, or you can have the asterisk here. Both of them mean the same thing. Okay, and what you can do afterwards is you can have int p2 is equal to the address of p. Now, the thing is here, if you put one asterisk, what does this mean? That the p2 points to an integer, which is not the case. P2 does not point to an integer. P2 points to an integer pointer, and this is why you need to have two asterisks here. Okay, so if you have with one asterisk, actually you will get an error. Okay, so you can still have the, let's say, nesting the way you want to have it. Now, if you take a look at the slides, we also have this, which is exactly the same. So array of 0, the address of it is ptr, which is exactly the same as the pointer ARR. Okay, so In this case, if you go to the last slide, you will find an example that you can trace. And to do that, always remember to draw your memory and to know exactly where every pointer points to. Okay, this is similar to what you will be doing in the tutorial, and I will also do one example at the start of the next lecture. Thank you very much. Please let us know if you have any questions, and please stay safe. Bye.